Every time you go online, your computer is having all these secret conversations, sending and receiving countless messages. Today, we're going to grab a digital magnifying glass, it's called TCPDUMP, and we're going to eavesdrop on those conversations and learn how to spot when something isn't quite right. Okay, let's get into it. Just think about it. Right now, there's a constant stream of data flowing in and out of your machine. Most of it, totally normal. But sometimes hidden in that stream are little clues, Clues that something suspicious is going on. And that's what we're here for. We're about to become digital detectives and learn how to read those clues. Okay, so you look at this, and at first glance, it's just a meaningless wall of text and numbers, right? I get it. It looks super intimidating. But I promise you, by the time we're done here, you're going to see a clear story hiding in plain sight. So, let's break this thing down, step by step. We're going to take this jumbled mess and untangle it piece by piece. We'll follow the evidence, connect the dots, and turn this weird code into a story you can actually understand. Think of us as detectives at a digital crime scene, and this log file, this is where we find all our clues. All right, so every good investigation needs a starting point, a baseline. We need to know what normal looks like. So we're going to start by looking at a totally normal, everyday internet request. This is our scene of the crime, before anything weird happens. And the very first step in pretty much any connection is something called a DNS request. So what the heck is DNS? Honestly, the easiest way to think about it is as the internet's phone book. It's that simple. See, when you type a website name, your computer actually has no idea where to go. It has to look up that name in the DNS phone book to get the site's real numerical address, its IP address. This is step one for almost everything you do online. Okay, so back to our log file, we can see exactly what's happening. Right here at 14:18 and 32 seconds, our computer, that's your .machine, asks a public directory, in this case Google's DNS, a really simple question. It's basically saying, hey, what's the real address for yummyrecipesforme.com? And boom, just a fraction of a second later, Google's DNS server replies. It's like, got it. The address you're looking for is 203.0.113.22. Perfect. Now our computer knows exactly where to go. The investigation has officially begun. Now, just because our computer has the address doesn't mean it can just barge in and start demanding data. No, first, it has to introduce itself politely. This is what we call a digital handshake, and it's a super important part of making a stable connection. And this whole introduction, it happens in two parts. First, our machine sends a little message over to the recipe website with a flag attached. See that S? That stands for start. Then the server on the other end sees this and sends a message back with its own flag, S. That stands for start acknowledgement. It's pretty much just saying, hey, I see you, I hear you want to connect, I'm ready to talk. These flags, they're kind of like a secret code for the whole conversation. We just saw S for start and dot for acknowledgement. As you look at these logs more, you'll see others, like P for when data is actually being pushed, or F for when the conversation is finished. It's basically the language of network connections. So, once that handshake is done, our browser finally makes its official request. You see this line? HTTP GET? That's our computer saying, okay, we're all connected, now please get me the main page of the website. And this is the moment the web page content actually starts downloading. So far, so good. Everything looks perfectly normal. Okay, so the connection to our recipe site keeps going. Everything's normal for about 2 minutes. But then our log file shows something unexpected. A brand new clue pops up, and it's about to change the entire direction of our investigation. The plot, as they say, is about to thicken. Just look at this timeline. At 14:18, we make our perfectly normal connection. But 2 minutes later, at 14:20, bam, our machine suddenly makes another DNS request. Now, we weren't expecting this. Why would our computer need to look up a whole new address right in the middle of a conversation? That's suspicious. And here it is. This is the aha moment. This is the clue that cracks the whole case wide open. Look closely. Our computer isn't asking for the original site, yummyrecipesforme.com anymore. It's now asking for a very similar but different site, greatrecipesforme.com. It's such a subtle change, but in a digital investigation, these subtle little changes, they are everything. Well, as good detectives, what do we do when we find a new lead? We follow it. We have to. So where does this new website address take us? It's time to investigate this unexpected destination and see what's really going on. So the DNS lookup for this new URL, it gives us a completely different IP address, 192.0.2.172. And hey, notice something else? Our machine is now using a different port to communicate, .56378. Literally everything about this new connection is different from our original legitimate one. Red flags everywhere. And sure enough, just like before, the logs show a new handshake starting up. But this time our machine isn't talking to the website we actually wanted to visit. Nope, it's setting up a brand new connection with this unsolicited, suspicious destination, greatrecipesforme.com. Our traffic has been hijacked. Okay, let's recap. We've gathered all the evidence, we saw what a normal connection looks like, we found a really suspicious new lead, and we followed it to a strange, unknown destination. It's time to put all the pieces together and officially solve this case. What we've just witnessed here is a classic redirection. Our network traffic, which was supposed to be going to a legit site, has been secretly rerouted to a new and probably malicious one. This spoofed site, it has a similar name to trick you, but it's at a completely different digital address. So how can you spot this yourself? It's really a four-step process. First, you establish your baseline. Watch the normal DNS request and handshake. Step 2, keep an eye out for any sudden new DNS requests, especially to domains with weirdly similar names. Third, investigate that new destination, that new IP. And finally, step 4, confirm that traffic is actually flowing to that new suspicious site. Look, if there's only one thing you take away from all this, let it be this. An unexpected and unsolicited redirection is a major red flag. When your computer starts a conversation that you didn't ask it to start, that's one of the clearest signs you can get that something is seriously wrong. So there you have it. You now have the basic tools of a digital detective. You know how to read the story that's hidden inside these TCP dump logs, and you know how to spot a suspicious plot twist when you see one. So the real question is, if you were to take a look at your own network, what secrets might you uncover?